In this module, we're going to turn our attention away from talking about the roles that concepts play in cognition and those three features that facilitate their playing that role, and turn our attention to research about concepts in cognitive science. We're going to look at four distinct areas of research on concepts. We're going to talk about them rather briefly and superficially. I'm not trying to give you an in-depth knowledge of the sort of research that goes on. What I'm trying to do is to give you a sense of the areas of research, the breadth of research about concepts within cognitive science. So we'll start off by looking at research on concept formation and conceptual development. Then we'll turn our attention to visual object recognition research. So research on conceptualization or categorizations of objects exclusively through vision. Then we'll look at research on categorization generally, not exclusively to vision. And finally, we'll end by looking at research on the role of concepts in inference and problem solving. So research into concept formation generally takes two different forms. On the one hand, there's research that can be described as transfer from exemplars. On the other hand, there's research that can be described as rule abstraction research. Now, the man pictured down here is Doug Bendit, and his work in the 80s really typifies transfer research. In transfer research, subjects are asked to sort, for instance, faces, but it could be anything, by given a training set, by trying to sort them according to categories, and being given feedback on that category or their sorting of that category until they get quite facile at it. Once they're facile at it, they're then asked to sort new faces or new objects into those same two categories, in effect transferring their knowledge of the category to new instances. Rule abstraction research usually asks subjects to determine the general rule or rules that underlie a category. So for instance, researchers using the Wisconsin card sort task, which is shown down here, ask subjects to sort cards into 4 different piles using feedback on each card. Success at this sorting task requires that subjects formulate the abstract rule or rules for the card categories based upon either color or quantity, shape, or some combination thereof. So for instance, if these are your categories and you've got this card here, you might sort it according to color and put it on this pile. You might sort it in terms of quantity and put it on this pile. Or you might sort it in terms of shape and put it on this pile. Now, these two paradigms of concept formation correspond to processes associated with explicit and implicit memory systems, which we'll talk about when we turn to the memory lectures. Indeed, the most commonly held contemporary account of concept formation, with the acronym COVIS, or competition between verbal and implicit systems, holds that two systems facilitate concept learning. On the one hand, the verbal system involves working memory, and it generates rule-based categories that can often be described declaratively, that is, verbalized. On the other hand, researchers associate the implicit system of concept learning with procedural memory, and it generates categories that are not easily declared verbally, oftentimes that are learned without even conscious awareness that you're learning them. Conceptual acquisition and conceptual change throughout childhood development has long been an area of research in cognitive psychology. And one way to think about this research is articulated nicely by the researcher shown here, Susan Gelman. This is a quote from her paper that's noted below here. Clearly then, children learn a tremendous amount about the world from the people around them. Moreover, this simple observation sheds light on conceptual development more broadly when we consider the following questions. What is the nature of that input? And what is the nature of the human mind that allows it to take advantage of that input? How do biases in the child and cues in the environment work together to enable learning? So research on conceptual development seeks to understand how children acquire concepts and how their concepts change through the course of development by asking and answering these kinds of questions. Next area of research is research on visual object recognition. This is research on categorizations of objects exclusively through vision. In research on visual object recognition, subjects are often shown pictures or line drawings of objects, and they're asked to identify them, to categorize them. The two approaches that emerge in this literature starting in the early 90s are Irving Biederman's recognition by components view, where we recognize something like a cup by breaking it into geometrical primitives, which he calls geons. So here's a cylinder, here's a handle. A cup is the thing that combines these two with the handle and the side of the cylinder. Recognition by components view supposes that's how we recognize objects visually. The multi-view theory has a different approach to thinking about how we recognize objects based upon multiple views of those kinds of objects. Now, this research is much more closely informed by vision research and by neuroscience, and it emphasizes the speed and robustness of visual object recognition. So we can recognize an object sometimes in as little as 300 milliseconds. We can recognize it across all sorts of partial occlusions, rotations, changes in light. General research on categorization in psychology that's not specific to vision looks primarily at the relationship between declarative knowledge, usually relatively low-level declarative knowledge like a knowledge of features commonly had by objects, and various effects in categorization such as typicality, reaction time, and problem solving, and we'll look at those a little bit later. So for instance, Eleanor Roche, pictured down here, became famous and really caused a change in the direction of concept research when she noted a relationship between an object possessing commonly listed features of a category and the speed with which subjects could categorize that object as a member of that object category. Not just how quickly we did it, but how typical we would think that object was of the category, which we'll talk about again a little bit later. Finally, research into inference and problem solving falls into two general areas as well. So research in psychology on inference involves these two different sorts of inferences. On the one hand, we have what one might call short-term or reactive tasks that involve exploiting relatively superficial information in more or less immediate interactions. That sort of STI information that we saw in the semi-symmetrical cone of conceptualization. Other sorts of inference studies focus on more information and time-intensive tasks. So for instance, research by Keith Holyoake, who's pictured down here, on analogical reasoning, tends to focus on how we can exploit relationships, perceived similarities between a source analog, something that we have experience with, we have a conception of, and a new situation, something that we don't have an experience of or a conception of. Analogical reasoning on this view works by identifying source analogs that share a number of important properties with the target that you're trying to solve the problem about, and then making an inference, an analogical inference about how many other properties had by our source analog are also had by the target analog, and thereby solving the problem. In the next module, we're going to turn our attention to theories about the nature of concepts. And we'll talk about two in this lecture, and we'll pick up a third in the next.